So now let's label for series attributes. The reason we want to label for series attributes is such that we can actually look into the attributes per se of different series. And in order to do that, we can teach our model what the series represent and how we can further process for different use cases. So for this labeling project, we want you to label the series attributes on all our thin slice axial CT chests. So in this study, there will be two studies or two series that are eligible for series attributes, which is here, which is the lung kernel, and this one, which is a 1 millimeter soft tissue or mediastinal kernel. So in order to label for series attributes, the first thing we want to do is to find the carina. So the reason we want to use the carina in particular is that it's an important landmark for us to measure the distance for nodules to carina as well, for example. But this will be done by the AI. But nonetheless, we want to teach the model where the carina is. So we want you to label it. So I would say overall, this is a pretty good level for the identification of carina. So as with any labeling exercise, the first thing you want to do is to zoom in to an adequate level that we can draw something on. And afterwards, what you do is on the right side, you open the series attributes tab and you click on the blue button here. So once this window here is turned blue, or the color correlated to the label, then you know that you're in the labeling mode. And once you're in labeling mode, the easiest way to label any contour is to just hold down your mouse button or your pen on your ThinkPad or drawing pad, and you just draw a line around it like this. And once you go back to your starting point, that's how there's a contour. Now, if at any point you made a mistake or you want to redo again, you can press C, or you can also choose click the clear freehand button up the top, then you can redraw. Now, let me show you another way to draw contours. For those with like maybe a slower computer or a mouse or inaccurate mouse, another way you can do it is by clicking. So what you do is you click once, and then you click again, and here a line is automatically drawn for you. And you keep on clicking consecutively multiple times. And this might be a longer process, but this will also give you a slightly more accurate process. And as you do that, you can see a line is fully drawn until you go back to the beginning. And that's how a line is fully drawn out for you for contour. And remember, you can always press clear freehand to delete and redo it again. So now that you have a contour like labeled, for each of the segmentation contours or for this labeling project, there is a whole series of correlated characteristics that we want you to fill in as well. This might look like a long list at first, but Catherine will go through all of them later, and trust me, it will be a much quicker exercise once you get used to it. So the first thing we want to look at is what we call the nodule lobar adequacy, which is essentially whether this series itself is good enough for us to assess for like nodules per lobe. So a quick way to do that is to quickly go through the whole CT chest, go through all the scans, like from top to bottom, looking into the lungs to see whether the scan is adequate for nodules. So I'll say overall, this we can see all the different lobes in this scan. So I'll say this is all lobes accessible. Secondly, we want to assess whether there's motion artifact in this scan. Overall, I would say, in the mostly central zone, I can appreciate most of the definitions. Maybe a bit of peripheral motion artifact, but overall, I would say, there's nothing that will affect our reading. And secondly, we want to look into is beam hardening. Similarly, I can't see any beam hardening that greatly affects the scan to the extent that we cannot assess for nodules. So I'll also say there's no beam hardening. And similarly, with image noise, I would say there's an acceptable amount of image noise for the same reason. Now, this looks like a post-contrast, but in the arterial phase. So I'll call this the arterial phase for contrast. And looking at the trachea, we can also then look into which respiratory phase it is. And this looks like a inspiratory phase scan for me. So I'll take that. And position-wise, this patient seems to be supine. So I'll call that the supine scan. And as we have established earlier, we also can appreciate the full scan range of the lung. So this will be adequate range of the lung. And all of these factors will combine to a definition, and this will be more a subjective assessment on how much you think this series is adequate for the study of nodules. So I would say this is overall adequate for nodules. And lastly, another important thing is to score this series on whether which kernel it is built on. As we have like know there are different ways we can reconstruct a CT data. So this like different filters. So this is a lung kernel, for example, and this is a soft tissue kernel. So as a result, I will label this as the lung kernel. And lastly, you if this is the most primary series, once again, this is a subjective judgment on like on this series being the best for nodule assessment. You can also click that this is the most primary series. So, and this is how you do one single label for series attributes for one series. And after you do that, I would recommend actually collapsing the tab such that it doesn't show. And then you do, once you do the next series attributes here, you can like, it doesn't occlude and like confuse you with different things. So similarly, we'll just do this one really quickly by zooming in. And once again, we'll draw here. Maybe one or two slices higher here. I think this is a good one. Oh, there you go. So say we draw here, and we'll just repeat the same, but with the next tab, with the new tab. And this is how you do series attributes for a study.